All right, so now we're going to be proving triangles similar. It is pretty difficult to prove that side lengths are proportional. You can do it, it would just be a very, very long proof. I'm not necessarily going to make you guys do those types of proofs. So then keep in mind then our only option would be to use AA similarity. Looking at the first one here, we're given, I should have said the diagram, and on the diagram we see angle A is congruent to angle E. But then in order to prove these triangles similar, we would just need to prove another set of angles congruent. And we have a pair of angles congruent using the vertical angles theorem. We can state that angle ACB and angle ECD are congruent. And so now we need to be careful with the order that we put our triangles in, but they are similar. I said triangle ACB because AC then corresponds with EC. So triangle ACB is similar to triangle ECD by AA similarity. That is how I did this proof. You can use corresponding side lengths proportional. It's just going to be a very, very long proof here. So for the 21, we are given the diagram. In our diagram, we have angle A and angle D are right angles. So I can say angle D and angle A are congruent by the right angle congruence theorem. Now I just need one more set of angles congruent to say that these triangles are similar. And that are these two angles here, because those are vertical angles. So by the vertical angles theorem, those two angles are congruent. Now we need to be careful about the order that we put these in. I use triangle ABC. If I did triangle ABC, then we need to do triangle DEC. That's by AA similarity. And then the last one here, this is a bit of a longer proof. We need to prove two pairs of angles congruent, not equal. Right now, we're given the diagram with the measure of angle A being 43 degrees, the measure of angle F being 47, and angle B and angle E being right angles. So by the right angle congruence theorem, we can state that angle B and angle E are congruent. I'm going to real quick just extend my page real quick so it doesn't keep jumping down. So now I can use either one of these triangles. I chose to work with this triangle here. And since it's a triangle, I know by the Triangle Sum Theorem that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. If I know that angle B is a right angle, then that means that the measure of angle B is 90 degrees. That's the definition of a right angle. So now I can use some substitution by stating that the measure of angle A is 43 degrees. I can substitute that in here. And stating that the measure of angle B is 90 degrees, I can substitute that in here. So using substitution, I then have this equation. Then I need to first simplify these two before I can do anything else. So I get this. And then using subtraction, I can subtract that 133 over to get this. We should now notice that the measure of angle F equals 47 degrees and the measure of angle C equals 47 degrees. So that would mean that the measure of angle F and C are equal. That's either substitution or transitive property of equality, depending on how you look at it. Well, if they're equal, then I know that they're congruent by the definition of congruence. So now I have one pair of angles congruent from the start, and I just proved a second pair of angles congruent. So now I can say that these triangles are similar. I do need to be careful on how I state this. I chose triangle ABC. If you do triangle ABC, then you would need to work with triangle DEF. They're similar by AA similarity. All right, and that is our proof.